Given question is from deadlock avoidance, and we will have to apply here Banker's safety algorithm to get the value of x here, this, okay, so that my system will be in safe state. First of all, when we used to start such kind of questions, we will have to obtain the need matrix. So the need matrix will be for each resources A, B, C, D and E, for each processes P1, P2, P3 and P4. So need we can calculate like whatever the maximum is there, maximum requirement minus its allocated. So 1 minus 1 is 0 for P1A. For P1B, 2 minus 0 is 2. Similarly for P1C, 2 minus 2 is 0. 1 minus 1 is 0. And then 2 minus 1 is 1. Similarly, if you will get all those values, this particular need matrix will be looking like this. So this is the need matrix, and if we will look at our available matrix, then you can understand that this particular A is 0 and B is 0. That means available resources of A and B, there is no any instance of A and B available. Among these available resources of A and B, you can easily understand that only process P4 initially can start execution, and if P4 wants to get its CPU, then it will have or it should have at least one requirement of or one resource instance of C. So let's say if I am taking x is equal to 1, and then within the available 0 0 1 1 1 my P4 can execute completely. That means P4 can execute, and after P4 my available will be equal to available whatever we are having 0 0 1 1 1 plus allocated to P4. So allocated to P4 are 1 1 1 1 0, and those will be added into 0 0 1 1 1. After that available will be 1 1 2 2 and 1. And you can see that with this particular available also system is in unsafe state. There is no any need which is lesser than or equal to this particular available. So x equals to 1 is not possible. When we will take x equals to 2, then again if we will see P4 will be executed. I'm writing x equals to 1, after P4 available will be there, and then again unsafe state. Now we will see if x is equal to 2, then can my system be in safe state? So if is x equals to 2, then also we will start with P4 only, just because only P4's request can be completed with 0 0 of A and B. So after completion of this P4, after P4 when x is equal to 2, my available will be equal to 1 1, then 3, then 2 and 1, just because in available allocation of P4 will be added. Now you just see after P4 P3 can run. P3 runs just because P3's requirement is less than or equal to the available. So when P3 runs, my available will be equal to allocation of P3 plus available, and it will become 2 2 3 3 and 1. And after that P2 can run, you can easily say that P2 is having less requirement than the available. Even then after that, available will become allocation of P2 plus whatever available we are having. So it will be 4 2 4 4 1, and at the end P1 can also run. So for x is equal to 2, we are having safe state. So option C is the correct one.